Hi there, we are going to be doing notes for another type of word problem, and these types of word problems are rates. And so every time we are talking about some kind of train, or if we're talking about a car, or we're talking about walking, these are all rates of speed, and this is how you approach speed rate problems. So I'll put speed here too, even though we can have lots of discussions on what speed means. But today in the video, I'm not going to be using percent, but we are again going to be solving rational equations. I'm going to be talking about fractions. I'm going to say rates such as miles per hour, and I'm going to give you some other examples of rates. We're going to be using the words less or more, and that's going to indicate if we're adding or subtracting. I'm going to say miles, which is a form of distance. And then the other unit that we are also going to be discussing is the unit of time. And in this case, we're going to use miles, or not miles, hours, but sometimes they're in seconds, and sometimes they're in minutes. Okay, so every time we come across these, here, we're going to take some, this is our example, but we're going to take a little bit of notes down here. Notes on rates, including speed. So specifically, we're going to talk about speed. And this is like, you've seen this in a car, and you've seen this in like how many, especially in a car or any kind of moving vehicle. So our basic formula for speed is distance equals RT. And if you've seen this before, great, we're going to use it, and you're going to continue to use it in many science courses and math courses ahead of you. So this is used if you have a rate and a time, you can find distance. But what you can also do is divide both sides by t, and you're going to get d over t equals to r, or r equals d over t. So another way to find, if say you needed time and you had distance and the rates, you could also use this formula. These are equivalent. Everything I'm in a box right here. The other way you can do this is d equals rt. You can divide both sides by the rate, and you're going to get d over r is equal to t, and t is equal to d over r. So today we're going to be using one of these three versions of d equals rt in order to solve some rational equations and to solve our word problems. So what you need to do when you come across these word problems is you need to decide what is your find. Decide on your find. Decide on a find. So for those of you who have never heard me say find your find, this is what our variable is. This is what we're looking for. If we're looking for a rate, our find is r. If we're looking for a distance, our find is d. If we're looking for some kind of time in seconds or minutes, then our find is t. So once we decide on our find, we can then decide on what kind of equations we're going to use. And today, in these speed type videos, they're kind of broken down into three different ways. If you're given a total distance, say you're given a distance and this is the total. So this is a subscript. This is in the bottom right hand corner of D. And they give you other ways to find the distance. So maybe they give you one distance and they say you travel another distance, and then the total distance traveled was this. Then you would be able to use this part up here to plug in. You would plug in RT for distance. Or sometimes they would say if your find, maybe your find was time, and then but they gave you the total rate or speed. So maybe they gave you the total speed, but they said there's the first rate that's happening and then the second rate that's happening, but together the speed total was this. So in this case, maybe you would use d over t and you would substitute it into here to find a total r. Maybe you had to find t. Or maybe they give you the time and you need to find the rate somehow. So maybe they said, total, this trip took some amount of time, like 4 hours or something. So your total time would be over here, and they would give you the total for maybe one direction of the trip and then the total for another direction of the trip. And then you could use this d over r and substitute it into this t so that you can find maybe the rate. So this part should be in your notes. And now we're going to try out our example problem. So we're reading our example. Emily drove, and I'm going to mark this text up while I read. Emily drove 1,500 miles to Disneyland for spring break. On the way back, she averaged 10 miles per hour less, and then the drive took her 5 hours longer. Find Emily's speed. She was driving along the way to Disneyland. So as I'm just scanning this, that's all I did. I just kind of read it to scan it, and now I'm going to break it down a little bit more. So she drove 1,500 miles. This is a distance. She's going to Disneyland, cool. On the way back, she averaged 10 miles per hour less. And so a rate can either be miles per hour, or it can be feet per second, or it can be meters per second, commonly used in physics. So that is going to be a rate. So now we're given 10 miles less. So that means subtraction is in there somewhere. And the drive took her 5 hours longer. So this is a time value. Okay, so we have a distance, a rate, and a time. And we need to find Emily's speed. So speed is also rate. Oh, it even says find. Our find is going to be a rate as she's driving back to Disneyland. So looking at our formulas down here, in the Emily problem, they said that there is some kind of total time where if you took the difference between her time going to Disneyland and coming back, you would get a total time of 5 hours, because that would be the difference. So this part would change too. So let's take a look at, let's write this t equation over here. So you have t, and well, we do know there's a t total. For Emily, it took her longer to get back from Disneyland than it did for her to go to Disneyland. So the difference, I'm going to write this down. The difference between trips, I don't know if that's between trips was 5 hours. So the key word I said was difference. So the difference, subtraction, difference means subtraction, difference, and you can write that difference is subtraction. This is in your bank for vocabulary. The difference coming back to Disneyland, what did I? The time it took to come back home, this is a subscript, so I'm labeling what this T is, minus the time it took to get to Disney is going to be the total of 5 hours. So the time it took to get back home minus the time it took to get to Disney is going to equal to 5. Now, what did we say earlier about this time? Well, I'm going to go back down to our notes. Time is also equal to the distance over the rate. So what I'm going to do now is I'm now going to write my distance. Oh, that's not my pen. Distance over r. Again, this is for back home. Minus the distance over r, and this is going to Disney, is going to be 5 hours. So my distance going back home was 1,500, and the rate it took me to get back home was, on the way back, she averaged 10 miles per hour less. So if it took Emily to get to Disneyland, if it took her some rate or R, it took her whatever speed or rate, but minus 10 miles per hour. So let's say her miles per hour was like, let's say she was going fast and saying she went 100 miles per hour. Then on her way home, she'd be going 100 miles an hour minus 10. So she's going slower. So when you find the difference between those two times, this is an entire time, this is an entire time, you get 5 hours. From here, you know how to solve this. So you can pause the video, you can try to solve for R, and then check your answers. Otherwise, I'm going to go through the process of how I solve this once more. So I'm looking at my common denominator, and my common denominator is going to be, there's a 1 over here, it's going to be R, and R minus 10. And so I will do this the way that I see most of you do this. You say, oh, I'm missing, actually I'm not going to do it that way. I'm going to do this by multiplying the common denominator all the way through. So this is my common denominator. I'm going to multiply it, I'll do it over here, R minus 10. So I think R minus 10's cancel, R minus 10's cancel. I'm left with 1500 R minus I'm going this way now. My R's would cancel, and I'm left with 1500 R minus 10 is equal to, now I gotta multiply this guy, 5 times R minus 10. And I'm going to go ahead and simplify as best as I can. This is going to be 5R squared minus 50R. If you need to do this part in your scratch work, you can go ahead and do so. You see this negative? I'm going to distribute this negative. Because before in my life, I've put a caution sign and told myself to be careful around negatives, and I would put parentheses around my term, so I would remember to distribute my negative. If you still need to put a caution sign about this negative and distributing it across parentheses, please do so. That's why you are taking notes right now. And at this point, I'm going to combine any like terms that I have. So this 1500R minus 1500R is going to go to 0. I'm left with 1500 is equal to 5R squared minus 50R. What do they all have in common? They all have 5 in common. So I can divide each expression by 5 and get 300. Oh, this should have been 15,000, my bad. So this is 3,000 is equal to R squared minus 10R. If I'm going to subtract 3,000 on both sides, I'm going to get R squared minus 10R minus 3,000. Okay. Great. So I'm going to take this with me, and I want to move it somewhere where, can I make this smaller? Oh no, my 0. Okay. Alright. So my notes actually went all the way this way. Sorry for the arrows. But I wanted to put this in the middle of the screen because even though you may say, I don't know how to solve for this, you actually do know how to factor this if you follow your combine and multiply t-chart like we've done before. So I have 2 binomials right here, and let's try to do this with a combine and multiply t-chart without freaking out over any numbers. So if I have negative 3,000, I need factors of negative 3,000 to add up to negative 10. I don't really know factors of 3,000, but I know factors of 30. Factors of 30 are like 5 and 6. And then I need it to get to maybe negative 1. So what if I did negative 6 and negative 5? That'll get me to negative 1. Oh, what if I add zeros right here? So if I multiply 50 and negative 60, I get negative 3,000. So just like we've always been factoring, now your rate is either R minus 60 or R plus 50. Now I'm going to use my zero product property. So R minus 60 is equal to 0, R plus 50 is equal to 0. I'm going to get R is equal to positive 60 or R is equal to negative 50. Now, in the rate and speed world, this negative sign means something different. Kind of means like she's driving backwards. So she's not really driving backwards to Disneyland, so we're not going to worry about this one. So our only answer is this guy, but check if it's an extraneous route. It's not an extraneous route. So you've calculated it. Fantastic. You need to tell me what this means. This means that on going to Disney, Emily drove 60 miles per hour. There you go. So this would be your answer. Whoa. Okay, I know this was a kind of a long video for not a very long problem, but make sure you write your summary below and that all your vocabulary words are defined. Take a look at how, because I added extra vocabulary words. Go over the problem again. If you have questions, please annotate with question marks and we'll bring them to class tomorrow, especially if you have questions such as factoring or you have questions on the concepts about how to choose time. Otherwise, if these notes are unclear, please bring those questions as well and get ready to practice tomorrow. Fill out your summary. Bye.